Hello everyone. Before getting into the video, let me introduce myself to you all. Myself Govind Raman, currently pursuing my computer science and engineering degree in Sri Venkateshwara College of Engineering with AI as my specialization. So, my today's topic is about dual mode operation in operating systems. Let us see the contents. So in this presentation, we'll be learning about dual mode operation in operating system, what is dual mode operation and its types of modes and a basic example, and we'll be learning about why is dual mode operation necessary and examples of dual mode operations, and we'll be studying the differences between the modes, and we'll be dealing with advantages and disadvantages, and finally the conclusion part. Moving on. So, what is basically a dual mode operation? An error in one program can adversely affect many processes. It might modify data of another program or can also affect the operating system. For example, if a process stuck in the infinite loop, then this infinite loop could affect the correct operation of other processes. So, to ensure the proper execution of operating system, there are two modes of operation, that is user mode and kernel mode. User mode. When a computer system runs user applications like file creation or any other application program in the user mode, this mode does not have direct access to the computer's hardware. For performing hardware related tasks, like when the user application requests for a service from the operating system or some interrupt occurs, in these cases, the system must switch to kernel mode. The mode bit of the user mode is 1. This means if the mode bit of the system processor is 1, then the system will be in the user mode. Kernel mode. All the bottom level tasks of OS, I mean the operating system, are performed in kernel mode. As the kernel space has direct access to hardware of the system, so the kernel mode handles all the process which require hardware support. Apart from this, the main functionality of kernel mode is to execute privileged instructions. These privileged instructions are not provided with users access, and that's why these instructions cannot be processed in the user mode. So all the processes and instructions in this mode is restricted to interfere with are executed in kernel mode of the operating system. The mode bit of kernel mode is 0. So for system of function in kernel mode, the mode bit of the processor must be equal to 0. Let us take a basic example. When the computer system executes on behalf of user application, the system is in user mode. However, when a user application requests a service from the operating system via a system call, it must transition, it must transit from user to kernel mode to fulfill the request. As we can say, this architectural enhancement is useful for many other aspects of system operation. At system boot time, the hardware starts in kernel mode. The operating system is then loaded and starts user application in user mode. Whenever a trap or interrupt occurs, the hardware switches from user mode to kernel mode, changing the mode bit state to 0. Thus, whenever the operating system gains control of computer, it is in kernel mode. The system always switches to user mode by setting the mode bit to 1 before passing control to the user program. So, why is dual mode operation necessary? So, it is necessary because of the security risk. Without dual mode operation, malicious code or harmful code could exploit vulnerabilities in a program or operating system, leading the system crash. It will lead the system to crash or even a data theft. And shared system. Dual mode allows multiple programs to operate simultaneously on shared hardware without interfering with each other. And it is even necessary for IoT security as well. Dual mode can enhance IoT security by separating the OS from user apps and controlling access to network and physical devices. Example of dual mode operations. Dual mode operating system. Dual mode is used in Windows, Linux, iOS. Windows uses dual mode to switch between user and kernel mode, ensuring that user apps doesn't have access to sensitive system data. Linux uses dual mode to separate the kernel space from the user space, allowing only the kernel to access system resources and hardware. iOS also uses dual mode to protect users' data and privacy by providing separate data protection class for sensitive files. So the differences between user mode and kernel mode. So the basic definition of these two modes are: user mode is restricted mode, which the application programs are executing and start, whereas the kernel mode is privileged mode, which the computer enters when accessing hardware resources. Modes: user mode is considered as slave mode or the restricted mode, whereas kernel mode is considered as master mode or privileged mode. Interruptions. In user mode, if any interrupt occurs, only one process fails. In kernel mode, if an interrupt occurs, the whole operating system may fail. Restriction. In user mode, there are restrictions to access kernel programs, cannot access them directly, whereas in kernel mode, both user programs and other programs can be accessed. Advantages of dual mode operation. Protection. The first point is about protection. Dual mode operation provides a layer of protection between user programs and the operating system. In user mode, programs are restricted from accessing privileged resources such as hardware devices or sensitive system data. In kernel mode, the operating system has full access to these resources, allowing it to protect the system from malicious or unauthorized access. Stability. Dual mode operation helps to ensure system stability by preventing user programs from interfering with system level operations. Debugging. Dual mode makes it easy to debug and diagnose problems with the operating system and applications. So the disadvantages of dual mode operations is as follows: performance. Dual mode operation can introduce overhead and reduce system performance. Switching between user mode and kernel mode requires a context switch, which can be time consuming and can impact system performance. Complexity. Dual mode can increase system complexity and make it more difficult to develop and maintain operating system. Security. Dual mode operation can introduce security vulnerabilities. Malicious programs may be able to exploit vulnerabilities in operating system to gain access to privileged resources or to execute malicious code. Conclusion. So there are three takeaways in this particular presentation, which is: dual mode operation is a security feature that allows the kernel to switch between two modes of operations, privileged and non-privileged. Dual mode provides security benefits such as preventing unauthorized access to system resources and protecting against malware and cyber attacks. Takeaway 3. Dual mode can also have disadvantages such as increased complexity and performance overhead, but its advantages outweighs its drawbacks. Thank you.